guys, and welcome back to another lesson in Algebra 1. So today's lesson is about real-world linear inequalities. So what we are going to do today is we are going to be doing this. So it's Unit 5, Lesson 14. And we're going to write a linear inequality from a word problem. And realize, of course, you've got x or y, so you can solve for x or y when you create your linear inequality. And I really like my students to define their variables, and so we will go over that and make sure that we are doing our variables. And then my sloth is reminding us that every problem has two quantities. You got to find them. So everything's going to have an x and a y, and we can solve those things. There's nothing to write up here in this top part in the way of notes. These are just common words or phrases that you can see for each type of inequality. So when we read word problems in this case, like this less than, it could have these kinds of phrases in it. If you see these kinds of phrases in your word problem, it's going to mean less than or greater than. Or I'm sorry, less than or equal to. If you see these kinds of phrases, it's going to mean a greater than. And if you see these kinds of phrases, it's going to mean a greater than or equal to. So I will refer back up to these when we go solving the problems. I'm going to go ahead and scoot on down, and let's see, here we go. Let's do this thing. So I'm going to grab my highlighter real fast because I sure do like highlighting. And it says, Jalaya is buying concert merch and can spend at most $95. A hoodie costs $38 and a beanie costs $9. And so part A, they want us to write an inequality that represents the different numbers of hoodies and beanies that Jalaya can buy. Well, we've got a bunch of numbers going on in here. And so I want to call attention to this here. Whoops, not Jalaya himself, the at most. Okay, so the at most, if we come up here and we look to see what we have, none of these are at most. Okay, so we can rule that out. Oh, look, this is at most, and it's less than or equal to. So we can see that the type of inequality sign that we are going to write for this is going to be this right here. Okay, and it's based on this phrase. So we're going to put this in our inequality. Okay, so the first step we're going to do is we're going to define our variable. So I'm going to make a let statement. This is just where we are keeping everything super neat and organized in our head so we know what everything means. I am going to say that X is going to mean my hoodie. And I'm going to say that Y means my beanie. Okay. And I can see that my hoodie is going to cost $38. So it's going to be $38 times every hoodie that I buy. So my X is going to be my number of hoodies that I buy. And my beanie is going to cost $9. So it's going to be $9 times Y number of beanies that I buy. I know that my inequality is this guy here because we just looked it up here, right? It's at most, and it's less than or equal to, and then 95. Okay, so Jalaya only has $95. They cannot spend $95.01. They have to like stop at 95 or less. They could spend 75. They could spend 65. They could spend nothing. But this is going to be my inequality to represent my spending for these two items. Alrighty, so let's look at this next problem. It says here, could he buy 2 hoodies and 3 beanies? And we want to show our work. Now, the way that we're going to know if Jalaya can do this is going to be if this makes a true statement. Okay, so we want to know, can he do this? And so my X and my Y, my X was my hoodies. I'm going to use X in this case is going to be 2 and my Y is going to be 3. So that's what I'm going to plug in. And this is why I define my variables, because I'm like, okay, where do I put this 2? Where do I put this 3? If I write my equation over again, I got 38x plus 9y is less than or equal to 95. And so I am going to spend $38 and I'm going to buy 2 hoodies. Okay, so I'm going to put that 2 in there for the x. And I'm going to spend $9 on every beanie, and I'm going to buy 3 beanies. Okay, and I'm going to put that in there for my y. Now, Desmos is a calculator you probably use in school, and it's a super awesome one. So I'm just going to type this in. I brought my Desmos over here. I got 38 times 2 plus 9 times 3, and I'm going to hit my equal side, and I can see it had gone off my page a little bit there. I can see that's 103. So let me move my calculator away. This side is going to equal $103. So if Jalaiah was going to buy the things that we said, 2 hoodies and 3 beanies, it would equal $95. They cannot do this. This is a false statement, okay? It's not less than or equal to 95. So this is a false statement. So we're going to write here, no. You know, that is too much money. Okay, cannot do it. And all this work shows us why, because we get down here to 103 is less than or equal to 95, and that just does not work. Okay, so as usual, if I am going too fast, just pause it and catch up, because of course I'm recording this ahead of time. So let's just scroll on down here. It says, if Jalaiah buys, highlight this. So we're going to say if they buy 1 hoodie, write an inequality to represent y for the possible number of beanies they can buy. Okay, so I know here that, again, my hoodie is x, right? So my x in this case is going to be 1. So I can write my equation. I've got 38x plus 9y. And they're wanting to know how much of y I can buy. So they're wanting to know how many beanies I can buy. Okay, so it's got to be less than or equal to 95. All right, so I can substitute that 1 in here for x. So we know we're going to spend $38 for 1 hoodie, and all the rest of the money we can buy beanies with. That's a lot of beanies. Alrighty, so let's see. So 38, I'm going to go ahead and subtract my 38, because 38 times 1 is 38, right? So I'm going to subtract my 38. And let me go ahead and change colors. This cancels. And I've got 9y is less than or equal to 95 minus 38. I could subtract that by hand, but I'm going to go ahead and just grab my calculator because we're allowed to. So 95 minus 38 gives me 57. Alrighty, put my calculator back over there. So that's 57. Now, if you know your multiplication chart pretty well, or your multiplication facts pretty well, you recognize that 9 is not going to divide evenly into 57. Okay, so we're going to end up with a decimal here, and that's fine in this context. All right, so let me go ahead and switch to, let's see, I'll go to green. This is going to cancel here, and I got y is less than or equal to, let me bring my calculator over here. Again, I'm going to take that 57 divided by 9, and that's going to give me 6.33333333. Well, we cannot buy 0.3 hoodies, right? Or 0.3 beanies. So the max number of beanies is 6. We cannot buy any more than 6. We'll have a little bit of money left over. about $3 left over, right? Okay, so again, pause it if you need to. I'm going to go ahead and scroll on up for the next problem. Okay, let me go ahead and erase this where I circled this here so that we can read and get our next one. Okay, it says Valeria has a jar of nickels and quarters. The total value is at least $8.50. Okay, and they want us to write an inequality about this situation. Well, let me go ahead and define some facts here. So they're wanting us to have, $8.50, and it is at least. So let's go see where we can find the at least. I look up here, I don't see at least. I look up here, I don't see at least. I look here, I don't see at least. Over here, boom, I see at least. So here's my at least. That lets me know that it's going to have this symbol when I write it. Okay. I'm going to define my variables. So I've got let, and then x equals, I'm going to make my nickels x. So x equals, number of nickels. And my y is going to be my number of quarters. And so because this was written in dollars and cents, I need to put my nickels and my quarters in dollars and cents. So a nickel, if we put it in a dollar form, it would be 0.05x. So it's 5 cents for every nickel, plus 0.25y for every quarter. My symbol is going to be this greater than or equal to $8.50. And this is my inequality. All right, so the next question wants to know, is it possible for Valeria to have 30 nickels and 20 quarters? Again, this is going to be another one similar to this guy here, where we're looking to see if we make a true statement. If we make a true statement, yes, this is possible, okay? And if it doesn't make a true statement, it is, not possible. So that's what we're going to do. Alrighty, so let's go ahead and write this out a little bit more. My x is going to be, my x is going to be 30, and my y is going to be 20, okay? And so my equation is that one that I wrote up here, so it's that 0.05x plus 0.25, because 25 cents for y, or 25 cents for a quarter, and 5 cents for a nickel. It's going to be greater than or equal to $8.50. I'm going to go ahead and plug this in. So 5 cents for each of the 30 nickels, plus 25 cents for each of the 20 quarters, greater than or equal to $8.50. Alrighty, let me go grab my calculator. And so I'm just going to put this in. I've got, 0.05 times 30 plus 0.25 times 20 equals, and that gives me $6.50 greater than or equal to $8.50. Okay. Again, this is another false statement. Okay, this is false. So is it possible for her to have 30 nickels and 20 quarters? No. She must have more. Okay, so she needed to have even more than that in order to have enough money to be $8.50 or greater. Alrighty, let's go ahead and look at this one here. It says if she has 40 nickels in the jar. So in this case, X is going to equal 40. Write an inequality. Oh, you know what? I think I must have a little typo here. To represent X, the number of quarters she could have. Okay, my quarters were Y. So I got a little typo on that page. All right, so my Y, that's what we're looking for. Okay, so I am going to use my inequality that I made again. It was 5 cents for every nickel. You know, from up here, it's 5 cents for every nickel. So I'm going to do 5 cents times 40 plus 25 cents for every quarter. And that is going to be greater than or equal to 850. Okay, let me grab my calculator and we can see how much. Oops. Let's see, we got 0.05 times 40, and that's going to be $2. So that's going to be $2 plus 0.25y greater than or equal to 850. I can subtract 2 from both sides. This is going to give me 650. And let's see, actually I can go ahead and switch colors on this. This can cancel. And I got 0.25y greater than or equal to 650. So I'm going to divide by my 0.25. Got a little squishy down in here. I got to where I was writing too big. And let's see, so I'm going to end up with my y is greater than or equal to 650 divided by 0.25. We can grab our calculator again. We don't have to necessarily know that in our head. We could divide it out longhand if we wanted to. But calculators are nice too. Okay, so we got 26. Yeah, 650 divided by 0.25. Put that in right. Good job. Okay, so what this inequality means is that she must have at least 26 quarters. So that's what that inequality means. That's what we just calculated. Alrighty? And then last but not least, we can scroll on down to the bottom. Okay, so let's scroll on down, and it says here we have Orion and 2 friends have $18 to spend at a food truck. A taco costs $3 and a lemonade costs $2. Write and graph the inequality that represents this situation. Alrighty, so if they have 18, like that's all they got, right? Like they have 18. That is going to be the most they can spend. They can spend exactly 18, or they can spend less than 18. Like they can spend 15 or 12 or whatever, but they cannot spend 1801 because it doesn't say that they can, right? So they have 18. That's it. We are going to define our variables. So let's go ahead and say let x equal tacos and y equal lemonade. And let's see, so we're going to say a taco is $3, so we can write 3 times the number of tacos plus 2 times the number of lemonades, which is y. And so that is my inequality. I can go ahead and draw a box around that. Now we are going to need to graph this, but we've got to figure out numbers that this could possibly be. Okay, so I said tacos is my x, so I'm going to go ahead and put taco down here. And I said y was my lemonade, so I'm going to go ahead and put lemonade over here. And we're going to have to kind of, and I'm going to try to write this sideways, not the best. We're going to have to work out, how to spread out our numbers. So to do this, I would suggest finding your x and y intercepts. Okay, so remember how we find that. Our x-intercept is going to be when y equals 0. Okay, so if we take this equation here, we end up with 3x plus 2 times 0 less than or equal to 18. So that drops out. We get 3x less than or equal to 18. So we end up with x less than or equal to 6. So down here, we need to kind of make this so that we can do 6. And I actually might do this up to 5. So I'm going to go ahead and just do 1, 2, 3, 4, 5, because I think for the purposes of this graph, we can just go up to 5. But the max tacos we could have is 6. So that's why I picked the graph this way. I'm going to go ahead and find my y-intercept. So let me, go and I will write that in a different color. So my y-intercept, this is when x equals 0. Okay, so if I write this equation, I'm going to put in 3 times 0 plus 2y is less than or equal to 18. 2y less than or equal to 18. We're going to divide by 2. And so we end up with y is less than or equal to 9. Well, what this figures out is that this lets us know that this side needs to go up to 9 because my y-intercept is going to be up here like at 9. So what I'm going to do is I'm just going to go ahead and go up by 2. I'm going to do 2, 4, 6, 8, 10. And my 9 would be right here. Okay. And my 6 would be over here kind of like off the graph. And we could, graph this here. Let's see if I can kind of freehand this, about like that. Okay. So that's what my graph would look like. All right. So the last question is, if they buy 4 tacos, my tacos were defined as x. So my x, I'm going to put 4 in that equation. Okay. So we've got 3x plus 2y is less than or equal to 18. We get 3 times 12. Whoops. You can tell when I do the math in my head as I'm writing. I end up doing goofy stuff like that. Okay. Do over. Okay. 3 times 4 plus 2y is less than or equal to 18. This is going to be 12 plus 2y less than or equal to 18. I can subtract my 12 from both sides. Let's see, we'll go ahead and grab a different color. This is going to give me 2y, so I'm going to come up here, 2y less than or equal to 18 minus 12 is 6. Divide by 2, divide by 2. I end up with y is less than or equal to 3. So what this means is if they buy 4 tacos, so if they buy 4 tacos, they can buy 3 lemonades. And lo and behold, the amazing part is that that's actually a point. That is my x, y. We said x was 4. We just found my y. So when we write that in XY format, we can graph this. So over here at 4 tacos and 3 lemonades, we're going to put a point right here. Okay. All right. If I went too fast, just pause it. Until next time. Bye, guys.